Good morning, students. In chapter force and the law of motion, we have just studied about the Newton first law, Newton's second law, and Newton third law. Now, this is the last part of the chapter. This is the conservation of momentum. And what is the meaning of conservation? Conservation means something is conserved. It's not going to decreases or increases. It is conserved. And I think you know about the momentum. I have already explained you in last lectures that what is momentum. If some body has the mass and the velocity, it means this body has a momentum. So momentum is the product of the mass and the velocity. Now there is some example for the conservation of momentum. Suppose this is a bus which is moving with a high speed. Since this bus has some mass in it and it is moving with a high speed, so it should have some momentum. Now this is a car which is initially at rest. It is not moving at all. It is initially at rest. And when this bus strike this car, what will happen? The speed of this bus is going to decreases while the speed of this car is going to increases. Initially it was at rest, but after striking by the bus, its velocity is going to changes. It means it will gain some velocity. Now, according to the conservation of momentum, it is said that in this interaction, that is the collision between the bus and the car, in between this interaction, the momentum before the collision is equal to the momentum after the collision. It means, what is the momentum before the collision? Since this bus has some mass, not some mass, it has a large mass. The bus has a mass and has a large velocity, so it has a momentum. And this car initially at rest, so the momentum of this car is 0. So we can say the total momentum is m into v. M is the mass of the bus and v is the velocity of the bus. And what will happen when it is strike with the car? The velocity of this bus is going to decreases. It means the momentum of the bus is decrease. But since this car gains some velocity, it means its momentum going to increases. The loss in the momentum of this bus is equal to the gain in the momentum of this car. It means after the interaction, after the collision, the total momentum of both the bus and the car is equal to the total momentum before the collision of this bus and the car. This is the conservation of momentum. Now I'm going to write the law of conservation of momentum. This is the law of, I think you all understand what is I'm going to explain you, what I have explained you, that is conservation of momentum. And what is the conservation of momentum? Actually the momentum before the interaction is equal to the momentum after the interaction. It means the momentum remains conserved. That is, we can say momentum can neither be created nor be destroyed. So law of conservation of momentum, when two or more bodies act upon one another, like these are the two bodies and they are acting upon one another, their total momentum remains constant. It means the momentum before the interaction is always equal to the momentum after the interaction, provided, this is a very important point, you have to write it, that is provided no external force. It is a compulsory condition. It is a condition that no external force should be here in between this interaction. No external force acting. Okay, this is a very important condition, that there should be no external force acting on in between this interaction. We can say momentum, according to the conservation of momentum can neither be created nor be destroyed. It remain conserved. So this is the conservation of momentum. This is not all the conservation of momentum. If someone asks you that write the conservation of momentum, this is only the law of conservation of momentum, only the theory. You have to derive all the expression of the conservation of momentum. Okay, So this is not all about the conservation of momentum. You have to write the derivation of this conservation of momentum. This is a derivation. I'm writing here. Suppose I'm making a figure for you, that is, it becomes easy to you to understand. This is a body A having the mass m1, and this is the body B having the mass m2. Okay, these are the two bodies having different mass m1 and m2. And suppose they are going with some velocity, with different velocity. They are going in the same direction with a different velocity. Since suppose the velocity of this m2 is u2 and m1 is u1. Suppose the velocity u1 is greater than the u2. Then what will happen? If they are moving in the same direction and the velocity of this ball A is greater than this ball B, what will happen? It will strike this ball. Okay, you can imagine it, and even you can use two balls to see this changes, to sort of this changes happen in this case. This is a ball A and this is a ball B, and they are interacting with each other. It means they are collide. So they collide, and what will happen? The velocity of both the ball will changes. Now this is the ball A having the mass m1. Now the velocity after the collision is v1, and of the ball B is v2. Okay, it's clear. So when you write the law of conservation of momentum, you also have to write the derivation of this law. So let two object A and B having mass m1 and m2 respectively, and they are moving in the same direction. It is very compulsory condition that you have to write they are moving in the same direction. Suppose they are moving in a different direction, what will happen? Actually, if you represent this velocity with positive sign, then you have to represent this velocity with the negative sign. It is very clear that, it should be very clear that we know that these are the vector quantity. So if this velocity is represented by a positive sign, then the velocity which is opposite to the initial one, you have to represent it by using the negative sign. So here in this case, we are taking an example in which two bodies are moving in the same direction. Okay, m1 m2 respectively, and having velocities u1 and u2, and they are moving in the same direction, Okay, now if A and B collide with each other, A collide with B, and after collision, here I think you have to write here A collide with B for t seconds, for t time, for time t. Okay, they collide with each other for a short period of time, that is t, and after collision the velocity of A is v1 and of B is b2. Is it clear? So first you should write all the things, all the symbols which you are using in the derivation. So you have to write all the meaning of these symbols which we are using. Okay, now what is about the momentum of this ball A, of this object A? So you can write here the momentum of object A. Momentum of object A before collision. We know that momentum is equal to mass multiplied by the velocity. So we can say before the collision, this object A has the momentum m1 u1. And momentum of the object A after collision, and what is about the momentum after collision? After collision, its momentum is now m1 v1. And suppose they are striking to each other for t time. So we can say the change in momentum. What is the change in momentum? change in momentum. How much momentum is going to be changed here? That is m1v1 minus m1u1. Okay, so this is the change in momentum. And what is about the rate of change in momentum? Rate of change of momentum of object A. It is m1v1 minus m1u1 upon t. Okay, this is the rate of change in momentum of object A. And we know that according to the Newton's second law, the rate of change of momentum is called the force. From where this force is applied on this object A. Actually, when they collide with each other, this A exerts some force on B and this B also exerts some force on A. And according to Newton's third law, we know that the force applied by A on B is always equal to the force applied by B on A. This is the law of action and reaction. So due to some force which is applied by B on A, we can say its velocity going to changes. So it means the rate of change of momentum is of A is this one, which is equal to the force applied by B on A. This velocity going to be changes due to the force applied by B on A. So let force applied by B on A is suppose F2. I'm telling here that I'm saying here that B applied the force on A, that is F2, and the A applied on the force B is F1. So it means according to the Newton's second law, according to Newton's second law, we know that the momentum of the body A changes due to the force applied by B on A. So we can say that F2 is equal to m1v1 minus m1u1 upon t. It should be very clear to you that is this is a force which is applied by B on A, not on from A on B. This is a force which is acting from B on A, due to which the velocity of the object is changes. Okay, so we can write here like the equation 1. Now about the object B. In the next page, momentum of object B before collision is equal to m2u2. And what is about the after collision momentum? After collision it will be m2v2. Now what is the change in momentum? How much momentum is going to be changed here? Now m2v2 minus m2u2. And what is about the rate of change of momentum? Rate of change of momentum of B is equal to m2v2 minus m2u2 upon t. This is the rate of change of momentum of object B. You know why the momentum, yeah, we can say why the velocity of the body B changes? Because some force is applied by A on B. So suppose I am writing here the force applied by A on B is F1. So I think we can write here, let the force applied by B on A is F2 and the force applied by A on B is F1. Okay, what is F1? F1 is the force applied by A on B. Now we know that since the velocity of the object B is going to be changes, it means the force which is applied by A on B is change the velocity of the object B. So we can write here that is the force applied on B is F1, which is applied by A. F1 is equal to, according to Newton's second law, you can write here according to the Newton's second law, F1 is equal to m2v2 minus m2u2 upon t. I think it is clear to all of you. It is clear to you. That is what is F2 and what is F1 here. So according to Newton third law, we know that the force which is exerted by A on B is always equal to the force exerted by B on A. This is the action and reaction. This is the law of action and reaction. The force जितना A ने B पर लगाया उतना ही B A पर लगाएगा. But here is the difference in these forces is this, that the direction of the forces are different. It means A applied the force on B in this direction and the B applied the force on in this direction. It means the force are equal but in opposite direction. And since we know that the force is a vector quantity, so if we are representing the F1, we can write here like this, that is F1 is equal to F2. But what is the condition here? In opposite direction. So this sign show that the direction of the force is opposite to this one. And we can write the value of F1 and F2. What is F1 here? F1 is M2V2 minus M2U2 upon T is equal to minus F2 is M1V1 minus M2U2 upon T. Cancel T by T. So you will get M2V2 minus M2U2 is equal to minus M1V1 plus M2U2. Now we can change the position. इसको इधर लेकर आते हैं तो ये नेगेटिव से पॉजिटिव हो जाएगा. That is M2V2 plus M1V1 is equal to, when it will go here, its sign will be changed. It will be M2U2. I think I write something wrong here. M1U1. Okay. M1 and U1. So M2U2 plus M1U1. Okay. Or we can write like this. M2U2 plus M1U1 is equal to M2V2 plus M1V1. It means the velocity, the momentum before the collision. This is the momentum before the collision of both the object A and B. And this is the momentum of both the object after the collision. It means the momentum before the collision is equal to the momentum after the collision. And this is all about the conservation of momentum. This is called the conservation of momentum. It means momentum, it's not changes, it remains conserved. There is some application of the law of conservation of momentum. First one is, this is a gun. Okay, this is a gun. And we fire a bullet from this gun. Okay, I'm firing a bullet from this gun. You get some jerk. We have learned it in Newton, in the portion of Newton third law. So what happened in this case? Actually, this is an application of the conservation of momentum. What happens? Initially, both the gun and the bullet are in rest. Initially, when the bullet is in the gun, initially both are in rest. Now, when we fire a bullet, what will happen? This bullet gains some velocity. Suppose, for example, initially the bullet, let the mass of the bullet is m1. I'm writing here about the bullet, the mass m1, and initially we know that its initial velocity is 0. So the mass of the bullet is m1, and when it is in the gun before the firing, its initial velocity is 0. And what is about the gun? This is about the gun. The mass of the gun is suppose m2. This is the mass of the gun m2. And when we don't fire the bullet, initial velocity of this gun is also 0. So initially, when we don't fire the bullet, initially both the gun and the bullet are at rest. So initial velocity of both the gun and the bullet are 0. Now, if we fire the bullet, so what will happen? If we fire the bullet, suppose it gains some velocity that is equal to the v1. Okay, it gains some velocity, and we know that according to Newton's third law, according to the law of action and reaction, we feel a shock jerk by this gun in opposite direction. So suppose the velocity of this gun is v2. Okay, the initial velocity is v1 of the bullet and the velocity of v2 is of gun according to conservation of momentum. Now put the value of both gun and the bullet, that is m2 u2. What is m2 u2? M2 and u2 is 0. So m2 into 0 plus m1 u1, that is m1 multiplied with the 0 is equal to m2 into v2. This is about the gun. M2 into v2 plus m1 into v1. Now both the things are both the values of velocity is 0, so we can say it is 0. 0 is equal to m2 v2 plus m1 v1, or if you write here, you can write like this: m1 v1 is equal to minus m2 v2. Now since the mass cannot be 0, because this is a scalar quantity, mass is not the vector quantity, so we can't represent it by using the sign. So this negative sign show that the velocity of this gun is in the opposite direction, that is the bullet, है ना. देखिए बुलेट को आप पॉजिटिव दिखा रहे हो अगर, और ये नेगेटिव आया, इसका मतलब क्या है? द वेलोसिटी ऑफ द गन इज इन अपोजिट डायरेक्शन. तो दिस इज एप्लीकेशन ऑफ द कंजर्वेशन ऑफ मोमेंटम. सेम इन द केस ऑफ द रॉकेट. जब रॉकेट ऊपर जाता है तो इनिशियली द गैसेस एंड द रॉकेट बोथ आर इन द रेस्ट, और जब गैसेस स्ट्राइक करती हैं अर्थ पे तो व्हाट विल हैपन? द वेलोसिटी ऑफ द गैसेस इज सो हाई, दैट्स व्हाई like this one, the velocity of the rocket gain is also is very high. Now there is some numerical problem based on the conservation of momentum. There is some numerical problems here. Okay, now the first numerical problem is this: a bullet of mass 10 gram is fired from a gun of mass 6 kg with the velocity of 300 meter per second. Calculate the recoil of gun. You have to calculate the recoil velocity of the gun. So for convenience we can make something like we can write here about the bullet, and this is a column for the bullet, and we can write here about the gun. So these are the two columns. For our convenience we can write like this: m1 is the mass of the bullet. Okay, what is the m1? M1 is 10 gram, and you should know that we can't represent the mass in gram, we have to convert it into kilogram. So divided by 1000 and convert it into the kilogram. And what is about the mass of the gun? That is m2 is equal to 6 kg. Okay, now initially when we fire the gun, initially the velocity of the bullet, we can say u1 is equal to 0, and also the velocity of the gun is 0. Initially they both are at rest. Now with the velocity of the bullet has the velocity is 300 meter per second, so we can say the velocity of the bullet after firing is 300 meter per second. This is the velocity of the bullet, and we have to find the recoil velocity of the gun. Okay, this is a very simple numerical problem about related to the gun and the bullet, which is actually depend on the conservation of momentum. So you will write here like according to the conservation of momentum, we know that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now we can put the value of these symbols, that is m1 is 10 upon 1000 into u1 is 0 plus 6 into 0 is equal to 10 upon 1000 multiplied with the v1 is 300 plus m2 6 multiply with the v2, we have to find. Okay, this is all 0, so it will be 0, cancel कर देते हैं इसको, है ना, तो it will become 3 plus 6 v2, and or you all know maths, so इसको इधर लाते हैं, it will be 6 v2 is equal to -3. इसको आप चाहो तो इसको माइनस लिख सकते हो, इसको जो भी आपको कंफर्टेबल होता हो, एंड v2 is equal to -3/6, that is -0.5 meter per second. This negative sign show that the gun is moved in the opposite direction of the bullet. Okay, because this is a vector quantity, and this negative sign show that this, if we represent this 300 by the positive sign, so this negative sign show that the direction of this velocity is in opposite direction. Direction of this gun is in opposite direction. This is about the conservation of momentum. I've explained you one example related to one numerical related to the conservation of momentum. In next video I will explain you more examples related to the conservation of momentum. Okay, till then, bye.